Alright, we are going to be solving equations with variables on each side of the equal sign. Here are the key concepts that you should have already had copied from class. And just a quick review. We have our step 1. We're going to make sure we simplify each side of the equal sign. We're going to use the distributive property when needed. That means when we have parentheses, we'll want to use distributive property to eliminate those. Step 2, we're going to use addition or subtraction properties of equality to get the variables on one side and the numbers without variables on the other side, and then we simplify. Last step is to use multiplication or division property of equality to solve and find our variable. When we solve equations, we want to first of all make sure that we write an equation with the variable terms on one side. And then if the equation contains grouping symbols, we first want to use distributive property to first remove all grouping symbols. And then again we have those identities. And this was when our variable is eliminated. And when our variable is eliminated, we get down to the very bottom. If those two values do not equal, for example, like 7 does not equal 10, then that represents no solution. But if my variable is eliminated and those values equal, like for example, maybe 4 equal 4, then that is true for all real numbers. Okay, here's our first example. We're going to solve each equation and check our solution. So first of all, again, I want you guys to draw your line down the equal sign. And my very first step, I want you to cover up the right side of your equal sign. And I have 2 plus 5k on that side. If I could, right now, simplify that side, that's where I would. But right now, 2 plus 5k is as simple as it will go. Then I want you to cover up the left side, and now we have 3k minus 6. At this point, if I could simplify that, I would, but since it's already in simplest form, I'm going to go on to step 2. And step 2 is to say to move your variables to one side. So I'm going to keep things positive, and I'm going to make this 3k move to the other side. Minus 3k from this side and minus 3k on this side. So that eliminates that 3k and 3k. And now I have, on the left, I have 2 plus 5k minus 3k is 2k equals negative 6. Now I'm going to solve this like a two-step equation. I need to get k by itself, so I'm going to subtract 2 from both sides. And I have 2k equals negative 8. And then divide by 2, and k equals negative 4. Okay, now I want to check, and when we check, we always want to check with our absolute original given problem. So when we check, we'll have 2 plus 5k equals 3k minus 6. So I said my k was negative 4, so over there's a k, I'm going to replace with a negative 4. 3 times negative 4 minus 6. So 5 times negative 4 is negative 20, and 3 times negative 4 is negative 12 minus 6. 2 minus 20 is negative 18, and negative 12 minus 6 is negative 18. Because both of those equal, my answer is correct at k equal negative 4. Alright, this one is a you do. That means I want you to try this one as best you can, and then when you're ready for me to explain it, then you can go ahead and replay the video. So pause it, try this problem as best you can, and then replay me when you're ready. Okay, so here we're going to start with subtracting 3w from both sides, and we have 2 equals 7w minus 3w is 4w, and we divide by 4 on both sides. And 2 over 4 can be reduced to 1/2 equal w. Now let's go ahead and check this problem. And again, wherever there is a w, you replace. We have 3w plus 2 equals 7w. And I'm going to replace w with 1/2, so 3 times 1/2 plus 2. Does that equal 7 times 1/2? 3 times 1/2 is 3/2 plus 2 equals 7/2. And 3 over 2 plus 2 over 2, well, we need a common denominator. So we have 3/2 plus, and we're going to have a common denominator of 2, so that'll make that top a 4. So adding those together, we get 7/2, which is good because that's what our right side equal at 7/2. Kind of pull this over here. Okay, so then my W does equal 1/2. All right, let's have this one be another you do. You try this one. And then, when you're ready, check with my work. Go ahead. Okay, now this one can be solved a couple different ways. You can either move this negative 7a, or you could move this positive 5a. It really doesn't matter which one you choose. You're going to both get the same answer, whichever one you do. However, I like to keep things easy, and when I can make it positive, I'm going to try. So this minus 7a, I'm going to add to the other side, and that will eliminate that negative. So then on this left side I have 5a plus 7a is 12a plus 2 equal 6. Okay, now we're at a two-step equation, so I'm going to subtract 2 from both sides, and I get 12a equal 4. Divide by 12, and a equals, reduced fraction is 1/3. So to plug in and check, we have 5a plus 2 equals 6 minus 7a, and I'm going to replace that a with a 1/3. And if you did, here at the original problem, if you instead subtracted 5a from this side instead of adding 7a, you know, you moved to this guy first, you should still get 1/3 as your answer. Okay, back to the check. 5 times 1/3 is 5/3 plus 2, and then 6 minus 7 times 1/3, we need to do our multiplication first, so we're going to do 7/3 here. Then I need a common denominator. I'm going to maybe do that in black down here. 5/3 plus, I need a common denominator of 3, which will make that top a 6. And adding across, I get 11/3. All right, let's try this right side. Hopefully we get 11/3. 6 over 1 minus 7 over 3. We'll get our common denominator of 3. And we have 6 on top. 3 times 6 is 18. 18 minus 7, we get 11/3, which is great because that's what we had on the left side. So my correct answer is a equal 1/3. Okay, this one is going to be an I do, and that means I want you to work this problem out as I'm working it out myself. So on this one, I see that my x is up here, and I have another x right here. Now I can rewrite this problem. This x over 2 is the same thing as saying 1/2 times x. Those mean the exact same thing. So to make this a little bit easier on myself, I'm going to rewrite this problem here to look like 1/2 times x. So now that I've written my 1/2 times x, instead of x over 2, I'm going to choose one of these x values to move. So I'm going to choose this 1/4 x to move to the left, minus 1/4 x. And 1/2 minus 1/4, you can do your scratch work, and that becomes 1/2 minus 1/4 is 1/4 x plus 1 equal negative 6. Now I want to subtract this 1 from both sides, and I have 1/4 x equal negative 7. Now I want to divide by 1/4 on both sides, and x equals, do my scratch work off here, negative 7 over 1 divided by 1/4, keep, change, flip, and negative 7 times 4 is negative 28. So now I want to check and make sure that that answer is correct. So I'm going to go over here to the right, and I have x over 2 plus 1 equal 1/4 x minus 6. X I said was negative 28. over 2 plus 1 equal 1/4 x, which we said was negative 28, minus 6. So negative 28 over 2 is negative 14 plus 1. And 1/4 times negative 28 is negative 7 minus 6. Negative 14 plus 1 is negative 13, and negative 6 minus 6 is also negative 13. That's great news, so I know that my answer, x equal negative 28, is correct. Okay, now this one is a little bit tricky. I haven't been telling you guys to check the left and right, but that's because the left and right are already in simplest form. So now I want you guys to take this right side of your equal sign and put your finger over it. I'm only looking at 6 times parentheses 5m minus 3. So in order to simplify this left side, I need to first distribute this 6. So I'm going to distribute the 6 to the 5 and the 6 to the negative 3. When I do that, I multiply and I get 30m minus 18. Okay, keep that right side covered up. Can I simplify 30m minus 18 any further? Well, right now, no, I can't do anything to that. So now let's cover up the left side, and I'm going to distribute this 1/3 to everything on the inside, on the right side. So 1/3 times 24 is 8m, and on the 1/3 times 12 is positive 4. Okay, now if I could simplify anything more on this right side, now would be the time that I do that. Lift up your finger off the left side, and now we have 30m minus 18 equals 8m plus 4. And that should look very similar to the other examples that we've been doing. So let's go ahead and solve. We're going to subtract 8m. And 30m minus 8m is 22m minus 18 equals 4. I'm going to add 18 to both sides, and 22m equals 22. Divide by 22, and m equals 1. Now, when we go into plug in, you want to, again, plug into your absolute original given problem. So whatever's right here, 6 times 5m minus 3 equals 1/3 times 24m plus 12. So we're going to do 5 times 1 minus 3 equals 1/3, 24 times 1 plus 12. We're going to do inside the parentheses, 5 times 1 is 5 minus 3 equal 1/3 times 24 times 1 is 24 plus 12. 5 minus 3 is 2 times 6. On the right side, 24 plus 12 is 36. 6 times 2 is 12, and then 1/3 times 36 is also 12. That's awesome news, so I know that my answer is 1. Okay, another example, I want you to do this one. And then when you're ready for the answer, go ahead and replay me. Okay, so on the right side, I see parentheses. So I want to go ahead and make sure I eliminate those first by using distributive property. So that's 18 minus 6s. And on the left, I can't do anything simplifying-wise to that side, so I'm just going to write it again, 8s minus 10. And I like to keep things positive, so wherever I can, I'm going to move to the positive direction and eliminate that negative 6s. So then I have 8s plus 6s is 14s minus 10 equal 18. Add 10 to both sides. 14s equals 28. Divide by 14, and s should equal 2. Well, let's make sure s equal 2 in my check. I have 8s minus 10 equals 3 times 6 minus 2s. And wherever there's an s, I'm going to replace a 2. And 8 times 2 on the left side is 16 minus 10. Inside here, we've got 6 minus 4. 16 minus 10 on the left side we got as 6. And still in the inside the parentheses here, we've got 6 minus 4 as 2, and 6 times 2 is 6, which also equals 6, which is awesome news because we know s equal 2. Okay, I would like you to try this one. See what happens when you get to the end of this problem. Good luck. Okay, so I look at this problem. The left side, 5x plus 5, I can't do anything with that right there. So I'm going to simplify the right side as much as I can. So I'm going to distribute that 3, and that makes that 15x minus 12. And then I can't distribute that 3 to that negative 10x, but I am going to drop that negative 10x here. Now, still looking at this right side, I can simplify even further. So I have this 15x and this negative 10x. So I'm going to combine those into 1, and 15x minus 10x is a positive 5x minus 12. Okay, so the right side is all the way simplified. I'm going to drop this left side down here so I can look at this, 5x plus 5. All right, now I'm going to subtract one of these x's to both sides. Well, what is 5x minus 5x? Isn't that 0? It eliminates it. So now I'm left with 5 equal negative 12. Well, does that equal 5 equal negative 12? No, it doesn't. So in this case, there is no solution. There is not a single number that you can plug in to this x here, here, and here for this equation to be true. So this can be written as that big circle with a line through it as no solution. All right, and you do this one and see what happens at the end of this problem. All right, let's try this. On the left, we need to distribute that 3, get rid of those parentheses, so I have 6b minus 3 minus 7. I'm going to just drop that 7 down. I can combine my like terms of negative 3 and negative 7, so that's 6b minus 10 equals 6b minus 10. Now I'm going to subtract 6b from both sides. And it cancels on the right, but also 6b minus 6b, well, doesn't that cancel as well? So that eliminates that variable. And I get down to the bottom and I have negative 10 equals negative 10. Well, don't those equal the exact same thing? So my answer to this problem is all real numbers. Every number that you could possibly think of, when you plug into b, it will always work. Pretty cool concept, huh? Anyway, these are your extra practice problems. I'd like you to try these as best you can. The odd answers are in the back of the book, so if you'd like to check your work as you work through them, go ahead and try those. Okay, see you guys tomorrow.